In this lesson, we're going to continue to look at the equations of sinusoidal functions. And in the previous lesson, we were given the equation of a function and we drew the graphs. Now in this lesson, we're going to reverse the procedure. So you're going to be given the data from the graph and you're going to be asked to figure out what the equation is. So we're going to find what the parameters are, a, b, c, and d, and then decide if it's a sine function or a cosine function, and then write out the equation. So just a reminder, A is our amplitude, B determined our period, C determined our horizontal shift, and then D determined the vertical shift. Now for B, don't forget that we have a little bit of a formula here. We can use 2 pi divided by B, or if we're using degrees, that would be 360 degrees divided by B to figure out our period. Okay, so let's take a look at this graph here. This is our parent function, our sine function. This is something you need to be extremely familiar with in order to be able to move things around. So for our sine function, A is 1 because our amplitude is 1. B is 1 because we're not shifting from the original parent function sine x. C is 0 because there is no horizontal shift. And D determines the vertical shift. We haven't moved up and down. Now if we were to try to solve for our period using B, this is given, I could tell it's in radians because of my values along the x-axis. So if I figured out the period here, that would be 2 pi divided by 1. Well, the period is 2 pi. And if you were to do the reverse, let's say we didn't know what B was, well, we can look along our graph and see that 1 full cycle is approximately 6 point what? Well, 6 and a bit. That's implying it's pi, 2 pi, so that would be 6.28. So if you did that and you went 2 pi divided by 6.28 to figure out what your B value is, you would get a B value of 1. So those two equations work in reverse of one another. They're inverses of one another, sorry. All right. All of that is summarized down below here. All right, let's take a look at the next page. So it says, when analyzing the graph of a sinusoidal function, you should first determine the values of the parameters, then write the equation. Now, we've got our parameters here, and they've also given us our equation. So our amplitude equation, max minus min divided by 2, our B value equation, where the period's 2 pi divided by B. We'll have a look at C on the graph and see how we can identify the horizontal shift, first if it's left or right, and then by how much. And then D, our vertical shift, max plus min divided by 2. Okay, and that's related to our median line. Some other important information down here. First of all, really nice summarizing graph of what everything is. And then you can see, and it's even listed on our graph, our max is our D plus A. Our min is our D minus A, so that might come in handy as well. Okay, and the equation for the median line is equal to your D value, and that's listed here. So this is also a nice little summary of everything all put together. All right, let's take a look at the first example and apply this. Example 1. Write the equation in the form y equals A sine B times x minus c plus d for the graph shown below. First, write the values of the parameters a, b, c, and d. All right, so for our a value is our amplitude, and that, just to write out our equation, is our max plus, not plus, minus our min, all divided by 2. So we have to identify our maximum and our minimum points. I'm looking at my graph here. It appears that my maximum is 3. My minimum is -1 divided by 2. So that would be 3 plus 1 divided by 2, or 4 divided by 2, which is equal to 2. So our A value is going to be equal to 2, because this was 3 and this was -1. Now, in order to figure out my D value is my max plus my min divided by 2. So I'm jumping around a little bit just because D is usually easier to calculate. So max plus min divided by 2. So that would be 3 plus -1 divided by 2, or 2 divided by 2, which is 1. So if you want, you can grab a straight edge at this point and also draw in your median line. Alright, so I drew my median line in, and you'll notice that that's where your sine function starts, because normally sine would start down here at 0 and it would go up to a maximum of 1. Well, now it's shifted up a spot, and so that's the starting point. And that's why our max and minimum have also moved up, but then it also looks as if they're higher than they would normally be. So let's see what's going on with our other parameters. So that's A and D. Now our B, our period, we can figure out because our B, where is it? Is our formula is 2 pi divided by the period. And how do I figure out what the period is? Well, I look at how long it takes for it to have one full cycle. And this is very similar to our first one there. I can see that one full cycle ends up here. And if I read down, that's going to be approximately 6.28. Okay? 6.3, 6.28. It looks like it's at 2 pi itself. So when we do that, we would have 2 pi divided by 6.28, which is 1. So the period here is, or the B value is 1, because the period is matching the period of the sine function. Okay, and then we've also got our C value. Now our C value in this case is 0, and I could see that because there is no horizontal shift. The key points are sitting at the same point, and when I talk about key points, I mean my starting value, my halfway point, my end value, my minimum, and my maximum are all at those points where they would be as if we were drawing a regular sine function. The difference here is the amplitude is bigger. The amplitude is 2, but it's not, our maximum value isn't at 2 because we've also shifted our graph up 1. So it would be at 2, but because we shifted it up 1, it's at 3, our maximum, and our midline is in a new spot. So now all that's left is to write out our equation. So y is equal to, instead of a, I'm going to write 2, and this would be sine of b, which would be 1, x plus c, well not plus c, minus c, sorry, because that's the equation, minus c, which is 0, and then our d value is 1 plus 1. Now the 1 and the 0, if we simplify our graph, you can leave it like that, that's fine, but it would be 2 sine x plus 1. Alright, so that's the equation for that graph. Let's try another one. Let's take a look at example 2. Now in example 2 it says write the equation in the form, and it's the same format, for the graph shown below. First write the values of a, b, c, and d. So let's start the same way. If I take a look here at my a value, my amplitude, I'm going to take a look at my max minus my min divided by 2 again, and I can see my maximum here is at 0, my minimum is at negative 2 divided by 2, so that would give me an a value of 1. Okay, if we take a look at our d value, max plus min divided by 2, so that would be 0 plus negative 2 divided by 2, and that would give me a negative 1. So the d value is at negative 1. So we can draw that line in, and it actually appears as if our line's already drawn in here. So y is equal to negative 1. Okay, so that's a and d. B, that's going to be 2 pi divided by the period. How do I know it's 2 pi and not 360? Because again, I'm looking at my x-axis and seeing what it's measured in. So if I look at my starting point, which is sort of hard to see here, and then see where it repeats itself. If I'm using this point here, that's sort of a difficult point as to where to measure. So I recommend the best place to measure is often along your median line. So it's nice here because you can see the crosshairs. You can actually measure where that point is, and that next point would be here, and you can see the crosshairs here again. If we label those 2 points, that's 0.25 pi and 2.25 pi. So if you subtract those, just to get the difference there, you would get 2 pi. So our b value is going to be 2 pi divided by 2 pi, which gives us a 1. So your b value is 1. All that's left now is our c value, and what you're going to be looking at is if this was the regular sine function shifted down, we would notice that the sine function would start in a different spot. So what I've done here is I've actually gone ahead and drawn in our parent function, our sine function, with an amplitude of 1 and a d value of -1. But I haven't done anything with the c value. The b value is the same as the sine function, so that hasn't changed. And you can see that if we're that red one there, if we were to actually do that, there's a little bit of a difference here between where I started the graph as a sine function and where it's actually sitting in on the blue function, right? So that difference there is our shift. So where is it shifted from and to is the question you're going to ask yourself. So it appears as if the graph has shifted to the right 0.25 pi, and that's what our c value is going to be. Okay, so your c value is a positive 0.25 pi, but you're going to notice when you put it in your calculator, or sorry, not in your calculator, in your equation, it's going in as a negative. Okay, so x is minus c, so x minus 0.25. All right, let's go ahead and write this into our formula. Our equation becomes y is equal to a, which is 1, sine of b, which is 1, x minus c, which is 0.25 pi, plus d, which is -1. So if we were to actually write that out, simplifying it, it would be sine of x minus 0.25 pi plus, not plus, minus 1. Alright, let's take a look at examples 3 and 4. I think you have what you need now in order to do the same thing we were doing, so go ahead and try example 3 and 4, find your parameters and write it into the equation, and see if you get the answers that match mine. So for example 3, you'd get that a is 3, b is 2, c is 0, and d is 0, and you get an equation of y equals 3 sine of 2x. Let's take a look at example 4. So here for example 4, a is 3, b is equal to 0.5, because our period, we can see, is 4 pi, and if you want to measure, you can measure at any point, but if you're measuring here from pi to 5 pi, the difference there would be 4 pi. For c value, you can see there, and I drew in my parent function, my sine function there, you can see there's a shift to the right of pi radians, so that would be minus pi in our equation, and our d value is up at 2. Let's have a look at example 5. So this is a little different. It's saying consider the function y equals 2 cos 4x plus 2. So cosine function instead of the sine function. And they're telling us that our range goes from, oh sorry, not our range, our domain, it's my domain because we've talked about x, goes from 0 to 360 degrees. So that's what they want us to graph on. Okay? But now it also says describe the graph of the function by stating the amplitude, the equation of the midline, the range, and the period, as well as the relevant horizontal translation of y equals cos x. So how did we get from this function to this function, essentially? B says verify your description by drawing a graph of this function using graphing technology. So the first thing I've done here is just to remind myself what the cosine function looks like. So under window, I've set my minimum to 0, my maximum to 360 for my domain. I'm going to count up by 90s because that's what they're counting up by in the graph on my page. My minimum for my y is -4 and my max is at 4 because I can see in my equation that, if I go back here for a sec, I can see in my equation that I've got a d value that's moving me up by 1, and I've got a 2 here telling my amplitude isn't going to be the same as before. But just to get a reminder of what the cosine function looks like when I hit trace. Okay, so now we want to figure out what the parameters are of this new function. So we can see, because if this is y is equal to a cos of b x minus c plus d, we can see that our a value is 2, my B value is 4, the C value is 0, and my D value is 1. Okay? So what does that tell us? Well, that tells us, because A is equal to our amplitude, that means that our amplitude is equal to 2. My B helps me determine my period. So we know that the period, and this is measured in degrees, so let's say the period is 360 degrees divided by B, in this case 360 degrees divided by 4, which would give us a period of 90 degrees. So one full cycle happens in 90 degrees. A C value tells us our phase shift, which nothing's happening, so there's no horizontal shift. We can just write that here. And then our D value, that's our equation of our midline. So our D value is equal to 1, which implies that our midline is at y equals 1. That's the equation of our midline. Okay. From this, we can also figure out our max and our min, right? Because our maximum would be D plus A. In this case, that would be 1 plus 2, or 3. And our min value is D minus A. In this case, that would be 1 minus 2, or negative 1. So that also helps with our range. The range of our function would go from negative 1 to 3. And I think at this point that's all the information we need in order to graph this. Now, it's good practice to graph this by hand without your calculator, but you'll always have your calculator with you if you want to put that in. But you also need to know that on our graphing calculators you're not necessarily going to see those exact points. So what I suggest doing is go ahead and start by just putting in your midline, the equation of your midline, and labeling your axes here. So we know that our range goes from negative 1 to 3. So if we say that this is 2 and negative 2, then we would have this as negative 1, 1, 2, 3. And that would give us our range would be represented there. The equation of our midline was at y equals 1. So I'm going to draw that in here with my straight edge as best as I can. That gives me y is equal to 1. Okay, so I just choose another color here. Cosine starts up at the maximum value, so I would say that's my first key point. And then it's going to end back up here at 90 degrees, right? At that halfway point, it's going to be down at its minimum value. So that would be halfway between 0 and 90, or at 45 degrees. They'll be down here. Okay? Now if we want to put that in our graphing calculator, if you just want to put in another function here, we could put in 2 cos of 4x. Make sure you close that, plus 1. Just hit trace. And you can see how that graph compares to the original. Okay, so you're starting up high, down low, back up again. And so we're getting 3 cycles, it looks like, in here. Oh, 4 cycles actually in here, which makes sense for a B value of 4. So you have 4 periods showing. So you go back to our graph here, you can see that would be 1 full cycle here, right? Starting up high, down low, back up again to the 90 degrees. And so you're going to see your maximums at 90 degrees, 180 degrees, 270, and 360. And you're going to see your minimums in between each of those functions, right? And then you're going to have key points halfway in between, so you can see them along that median line. So go ahead and draw all 4 of those cycles in. So this is what you should have at the end, which is comparable to what we had on our graphing calculator. Okay? Alright, let's take a look at example 6. It says consider the function y equals 3, sine of 2, and then we've got x minus 45 degrees. And there's a little communication tip in the corner here, which is something pretty important. It says the degree symbol on 45 indicates that the independent variable x is measured in degrees. If no degree symbol is present in an equation, assume that x is measured in radians unless stated otherwise. So that's really important. That's a really good way for you to identify what we're measuring this in. Alright, so in this question, similarly to the previous one, it says describe the graph of the function by stating amplitude equation of the midline, range and period, as well as the relevant horizontal translation of y equals sine x. So let's just start by getting our a, b, c, and d. And as you can see above, I wrote out the form of the equation, so we can easily do that. So our a value is 3, our b value is 2, our c value is 45 degrees, and our d value is going to be 0 because there is no d value here. Alright, so from there, if a is equal to 3, then we know that our amplitude is also 3. If b is equal to 2, then we know that the period is going to be 360 degrees divided by 2, or 180 degrees. If c equals 45, that means that there's going to be a horizontal shift to the right of 45 degrees. And then our d value is 0, which means that our midline is at y equals 0. Okay? Now from here, we can get our maximum and our minimum, because our maximum is going to be d plus a, which would be 0 plus 3, or just 3. Our minimum is d minus a, or 0 minus 3, which is negative 3, which implies that our range would go from negative 3 to 3. Alright, so let's put this in our graphing calculator. I can clear out what I had before here. Alright, not all of these equations are easy to put in to the graphing calculator. So how do we put this one in here? So 3 sine, and now in here they've opened the brackets, so we want it outside the brackets. We're going to need a second set of brackets, so 2, then open bracket x minus 45, and close the bracket there, and then close the other set of bracket there. Now double check my window. I'm still going from 0 to 360, counting up by 90s, and it's going from negative 4 to 4, and that's going to accommodate what I need, so that's good. Because I can see my range goes from negative 3 to 3, so that's fine. And now hit trace, and you can see our function being drawn in here. Now I can see that's going between the 90-degree mark, so because I set my scale to be 90 degrees, I'm actually going to change it here to 45 degrees. And part of that is because we saw that our graph is shifted 45 degrees to the right. So if I change that here and have it counting up by 45 degrees, look at what that does for my graphing. I can see those points that it's going through, and that makes graphing just that much easier, so I can see where those key points are. Okay, so let's go ahead and draw this in on our calculator. Now if you want, before you do that, if you want to just put in the sine function, just so you can compare, you can go ahead and do that too, and you can see how that compares. So you can see that our sine function, right, our regular sine function, starts at 0, 0, whereas this function isn't starting at 0, 0. It's starting down at 0 and negative 3. And then our sine function also has a maximum of 1, where our new function has a maximum of positive 3. And we can see that the period is different, because this is one period is 360 degrees, whereas with this new one, I've got a period of 180 degrees. So I've got two functions for the one sine function in there. So that's important to see those differences too. Okay, let's go ahead and graph this on in our notes. Okay, so we can put in those in-between points like we did on our graphing calculator, because that's going to help us with our graphing. Now our minimum was negative 3 and our maximum was positive 3. So if we leave our scale the same as we had it before, that should accommodate that as well. Okay, and now our starting point is shifted 45 degrees. So normally I would want to start my function here at 0, 0, but now because it's a shift to the right of 45 degrees, I'm going to start my graph here. So maybe in red here, I'll just put in, oh, I lost my 45 degree. I'll put in where I would have originally gone. I would have originally gone here, here, at positive 3, down to 90, and then halfway between I would have down to negative 3, and then back up to 180. And that gives me one full sine function with a period of 180 degrees and an amplitude of 3, right? We can see that would be like this. But now instead, I've shifted everything over. So if we use another color here, it would be a starting point at 45 degrees, a maximum at 90 degrees, and so on. You can see how everything is moving over and back up here. So then this would be our new function that's shifted over, right? So I can erase that red one. And you can see if I wanted to start at 0, I actually have to go back down. So I'm starting down here at negative 3. And then we're going to do that all over again for the other side. So go ahead and complete this graph. Now at this point, you actually can't get a full other cycle in because you can see the starting point and we go up and down. So that would be one cycle, and here, oh, we can fit in the other cycle. It's very tempting to complete this up here, right? To see that rest of the cycle, but we don't need that. It is a full cycle at 180 degrees, and that's where that's done. So that's our graph there. And let's label it because we've got another graph that they want us to put in here. So this would be y is equal to 3 sine of 2x minus 45 degrees. Okay, going back up here, it says, how would the graph of y equals 3 cos 2x plus 45 be the same? How would it be different? So I see two differences right away. I see that we're using cos instead of sine, and I see that instead of a minus 45, we have a plus 45. So how does that affect our graph? Well, let's put in our graphing calculator and have a look. So we've got lots going on here. I'm just going to get rid of the sine function and put in the 3 cos of 2x plus 45. So plus 45 is telling me that I'm going the opposite direction. It's a shift to the left instead of a shift to the right. So that's my first function, our sine function that we already did. And now here's my cosine function. And because it's a shift to the left, let's actually change our window so we can see what's going on the other side. I'm going to go from, instead of 360, let's go from negative 45, because that's essentially where we're going, right? And then you can see that cosine, because it starts up high, you can see it's starting up high at that negative 45 degrees at a maximum of negative 3, and then coming back down and up and down and so on. Okay, so let's graph that in our notes here. So in our notes, I'm actually going to extend my graph in the other direction. Okay, so I just shifted my scale over a little bit so I can see that negative 45 degrees. And if we want to continue our sine function over, that would just mean that we would go up to that negative 45 degree mark right here. So we can extend that just like so. Now our cosine function, I'm going to use a different color altogether. And we can see it started at that negative 45 degrees up here as a maximum. Okay, and then we went down through 0, 0, and then a minimum at 45 degrees, back up to 90, and then a maximum right up here. So when we're looking at that, if we look at one full cycle, we go down, and there's your cosine function. Okay, and we can see that this is going to repeat itself. So let's take this all the way to 360 and see what it looks like. Alright, so this is what your graph should look like, and you can see I labeled it as well. Now in terms of what's the same and what's different, well, the period is the same, the amplitude's the same, the range, the maximum, and those are all the same. But what is different our x-intercepts, and that's because of this horizontal shift. So our x-intercepts have also shifted, and because of that, so has our y-intercept, and those would be different as well. Alright, let's take a look at example 7. In example 7, we're taking everything we've learned and trying to match these graphs with one of the equations below. So each graph has one match. Now, when you look at these graphs, we're going to be looking at the A value, B value, C value, and D value, and you can interpret that from the graph and then pick it out in the equation. So let's take a look at graph 1. In graph 1, just write it down here, graph 1, I can see my maximum and my minimum. So my maximum is 5 and my minimum is -3. So from that, I can determine my A value, and my A value is going to be 5 minus -3 divided by 2, and my A value is going to be 4. So I know it's not going to be equation 2, but all the rest of them have 4 as their A value. Now I can figure out my D value similarly, because that would be 5 plus -3 divided by 2, and that would give me a value of 1. So again, that actually didn't help. What about my B value? Well, B is my period, so if I take a look here, and if I get from one period to the next, let's say if I measure, let's say, from here 90 degrees to here, well, what are these counting up by? It looks like 30, 60, 90. So that would be 180, that would be 210. So this would be 90 degrees, and this would be 210 degrees. So the difference there for my B value would be 360 degrees divided by the period. And we can see that the period, 210 degrees minus 90 degrees, and that would be 120 degrees. So that would be 360 degrees divided by 120 degrees, which would give us a B value of 3. So now I know it's not 1 and I know it's not 2. So it has to be either 3 or 4. Now what's the difference between 3 and 4? One's the sine function and one's the cosine function. Okay, well, if my D value is 1, that means that my axis of, my midline is at 1. So I can draw that here. Oops, that's not a straight edge. So that would be at y equals 1. And we can see where we're starting. So it looks as if I'm starting at 1 and then I'm going down to a minimum and then back up to a maximum. So will that be a sine function or a cosine function? Well, it's still sort of hard to tell, but we can see that for both of these functions, there's a horizontal shift of 60 degrees. So if I took a look at that, 60 degrees would be here, okay? So if I take a look at that, and if I actually look at that higher up along the midline, that would actually make the most sense. So that means I've shifted to the right, so I should actually be evaluating my starting point here. Well, and then I'm going up and then back down. Well, that's definitely a sine function. So if you want to see how that actually works, right, that would be a sine function, not a cosine function. So there's two things here. One, I looked at the horizontal shift, but then I also moved that shift along the midline to see the starting point and then the behavior of the function. So that means A is definitely 3. Okay, so that would be graph 1 is equation y equals 4 sine of 3 x minus 60 degrees plus 1. Alright, so let's erase all this and have a look at graph 2. Now for graph 2, we're going to find the exact same information. I'm going to just, I think I'm going to do it up here so that we can keep the graph in sight as we're working on it. So my A value, I've got my maximum here's at 5, my minimum's here at -3. So that's actually, I'm going to end up with the same a value and d value as before. So that's an a value of 4 and a d value of 1. So let's draw that midline in again. Okay. So an a value of 4, d value of 1, that means that graph 2 is out again. So that's not useful to us. And we've already figured out graph 3, so it's not that one either. So what do we have left here? Well, it's either going to have a shift of 90 degrees or a shift of 60 degrees. And they're both cosine functions. So cosine function starts high and then back down. So if I look along my midline here, a shift of 90 degrees would be here. Okay, and that means that I'm starting high and then coming back down, and that looks promising. Okay, that looks good. If you want to just evaluate to see 60 degrees, that actually is not going to work because I would have to divide these into 3 to get 180, right? Divided by 60, that would be thirds, and that's not going to be that maximum value. So we know that this is now going to be graph 1. So for graph 2, that's going to be 1. Y equals 4 cos of x minus 90 degrees plus 1. And that's a perfect fit for that equation. Another variable that we didn't look at here for 1 versus 4 was our b value, and that would have also helped. So if we took a look at one cycle here along the graph, if I start here at 0 and then the next repeat is here is 360 degrees, the b value would be 360 degrees divided by the period. Well, the period's also 360 degrees, so that would mean we would have a b value of 1. And then looking here, that would also be equation 1 because equation 4 has a b value of 3. So that would be another piece of evidence that would tell us if the phase shift wasn't helping you there. That would also tell you that the graph 2 is equation 1, not equation 4. So that's it for today's lesson. I hope you were able to apply those parameters to the different equations, sine and cosine, and have a better understanding of how they both affect our graph and how we can get information from those graphs. Thanks for joining me.